now we're coming to our final highlight of the conference. I'm very excited. I think I'm for over 20 years in solar, and been I can luckily say that unlike many other people in other jobs after 20 years who are bored, I'm very often excited. And one of these moments has been the last 2 days, and now in particular with the latest executive panel coming up, where we really want to discuss the takeaways and the learnings from yesterday and from this morning. And we want to talk a little bit on the higher level. What are the hottest trends in solar module design to decrease cost and increase output? So we have a very esteemed international panel here with participants from Asia, Europe, and a very early bird from the West Coast of the US. And let me quickly introduce the panelists. So first, on the left side of this this slide, you can see Danny Chan from Jinko Solar. She's part of Jinko Solar's leadership team. She has extensive experience on scaling businesses in the solar industry. She's credited with leading the execution of Jinko Solar's market positioning strategy from the front, contributing hugely to the company's impressive growth as a market leader. We are very happy to have Danny with us today. Then we have also European by nature, but based out of China, Henning Schulze, who is the corporate assistant president at JA Solar. He's a solar PV professional with more than a decade of work and experience in this field. Henning leads the European team of JA Solar in his current role. Beyond and before JA Solar, Henning has worked in project development, EPCs at an IPP, and also with a European solar cell and module manufacturer quite a while ago. Welcome, Henning. Then we have another European representative, that's Gonzalo de la Viña, who is the head of the module business at Trina Solar. He's a seasoned solar expert with experience in developing strategies for various markets and segments, leading teams and supporting key projects. And he works with Trina as the head of its European module business since 2016. Before joining Trina, Gonzalo served as many others in this sector, also for other leading solar renewable companies, and had also leadership roles there. Then we have from China with us Yun Liv, who is the vice president and head of solar at Longji Solar. He joined Longji in 2016. He's credited with leading the company to have broken the world record of several PV module power and efficiencies for, I think, 7 times. Maybe it has been already more because it's happening so often. Jun has over 100 patents in the field of solar PV technology and holds a PhD from the National Institute of Material Research at Nanjing University, and he's also an associate adjunct professor of the famous University of New South Wales in Sydney. Then we have with us Huang, who is the vice president and CTO of Verizon Energy. He has worked also in the past with many other reputed names in solar wafer cell and module manufacturing in similar leadership roles. And Zhang, with his industry knowledge, has been also a contributing member to several standard committees and is also the funding director of a state key lab of PV science and technology in China. Welcome, Jiang. Then we have, last but not least, as I said, our early bird, and yeah, probably the veteran but still active, very active in this field, Peter Aschenbrenner, who's the Chief Strategy Officer of Maxion Solar Technologies, the planned spin-off of SunPower Corporation, where Peter has over 35 years of solar industry experience, and before moving to Maxion, he was working for SunPower, where he was until now the Executive Vice President for Corporate Strategy and Business Development. And before he got driving SunPower's corporate strategy, exploring many things, he also worked in the past, like our keynote speaker, Charlie Gay, at Siemens Solar and Arco Solar. So he brings many, many years of experience to this panel. Welcome, Peter. Happy to have you. So let's start. Maybe we can now switch on our speakers so that we can see all of them. Min, can you just put another slide for the background so that we have, yeah, okay. So, Gonzalo has the big one, the moment. So it will be like this.
We also have the biggest wafer.
Okay, that's what we not want to discuss so much today about. So I think we really want to talk about the big picture here. It's not about who has the biggest module. It's changing anyway very quickly, as we've seen in the last few months. So what I really want to do today is, unfortunately, we are not sitting in one room, which I would prefer also to have the audience with us. But nevertheless, I would like to have that a very interactive panel. So if you, what I suggest is that you can control your microphone on your own. So I suggest actually you go on mute if you don't speak, but if you speak actually, then you unmute yourself. So like in a conference with these old microphones where you always had to push the button when you wanted to speak and switch it off. And if somebody says something which you find interesting and directly want to talk about and answer, please raise your hand and then start talking so that we don't have 2 or 3 people doing the same at the same time. I also like to encourage the audience to participate. So please ask questions, give us comments in the panel. I try to integrate that into the moderation so that we really have a vivid, interactive 1.5 hours here. I think we have a lot to share and a lot to discuss. So much is happening. What I would like to do is I really would like to span this this discussion, not just, of course, the base is the module, but I want to go also beyond that because, of course, it has so much impacts also into the system, into LCOE, even if the role of the module has, at least from a cost perspective, somewhat declined in comparison to the past. But why don't we start basically in the beginning with the evolution of solar module technology. And look a little bit back on what we've seen in the past and what we've reached today. So we don't have to go back to the 1950s to what Suleiman showed, but maybe go somewhat back and maybe we can start actually where when Peter has started in the industry with Arco and Siemens. So Peter, you are here the veteran and have the most experience bringing to this panel. What actually surprised you most actually when we look back actually and then with looking back and then actually only looking at what has happened in 2020, what was the biggest surprise to you?
I think can you hear me okay, Michael?
Sure, wonderful.
Yeah, I think the biggest surprise for me over the past, say, 15 years or in the last year was the remarkable progress on cost reduction in solar panels. Uh, I think if we look back and look at expert predictions or perhaps even our own predictions about how quickly costs could be reduced, we've been consistently wrong on the upside. And so that, and I think we all understand the impact that's had on market growth and LCOE reduction and cost effectiveness of solar. So it's been amazing to watch. And, you know, people have been talking about cost asymptotes now for a very long time, and we haven't reached them yet. I think one of the topics of this forum is, you know, how big is too big, or have we reached size limits? And I think people have been talking about that theme also. So what has been most surprising for me has just been the consistent cost reduction and development of the technology.
The income statements for everyone. So so maybe Gonzalo, you're at least on my screen. You're sitting next to me. what surprised you most actually in this year? You're also in the industry for a while.
Well, now I have to go a little bit to the past. I mean, Peter, I think you were at Siemens Solar. I was at Siemens Semiconductor a long time ago. This was like in 1999, 2000. This is when my career started. And actually, which then became Infineon Technologies. And we were selling DRAMs, dynamic random access memories for the computer servers and all this stuff. And at that time, when I started in 2000, it was a highlight because we started were the first ones to actually introduce 300 millimeter wafers. So I think it's quite ironic that 20 years later, now at Trina, you know, now that I'm 11 years in solar, the 300 millimeter wafers catching me again. So at that time, 20 years ago, we were celebrating it. It was a big stuff. You know, 20 years later, I'm celebrating again the 300 millimeter wafer. So that's quite ironic. And I agree with Peter that it's amazing what we can do on the price reduction side.
But and if you look at actually the last half year, so what surprised you most? Also, I don't know, so being active in the market and actually also on the sales side. So what with this large modules coming so quickly? So what was the?
Yeah, definitely. I mean, when I started in 2009, at my former company, I think we were 200, 205, and this was already the max. And now with our new Vertex, with the 210 millimeter wafers, we're now going to 500. And what surprises me, to be honest, is the big acceptance that it has in the market. I mean, regardless with whom you talk, with which partner you talk, the interest is 100% there. I haven't seen anybody who's saying, oh, for this reason or that reason, I'm not interested. This is not the case at all. Because everybody's looking at BOS costs and everybody's spending his time, you know, how to reduce them. So this is, of course, with the 210 or with the 182 millimeter modules, you know, it's a big step in the right direction.
Okay, wonderful. Danny, so what surprised you most in the last 6 months?
I think regarding to the price, this is the most frequently asked questions. So whether now this cluster is the bottom price or how low can we go? So I think currently the solar module production cost is pretty much close to the direct material cost plus the power consumption cost, which is inevitable. So, for example, that's because of the rush demand of Q3 and Q4. So the solar module price is for sure will increase in Q3 and Q4. So it doesn't mean that the cost will always drop down. It's, you know, that because now it's very simple. That's it depends on the direct material cost, like the frame cost, glass, and wafer as well. So I think the only feasible opportunity for further improvements that I can see is to increase the power outputs per panel, therefore to reduce the cost per watt. And so, you know, that's according to the technical roadmaps, that the mainstream outputs of the panel will upgrade at least or at an average rate of 50 watts per year, or even bigger. So in 5 years, that's the panel will be up to 800 watts at least. So I can predict that the cost in short term or in short and middle term, that it will further drop down 10 to 20%. Largely depends on the panel power increase. So, but how to do that? I think that I think it's relying on the more advanced module technologies and the process optimization to increase the energy density of the panel. For example, in the module sites, that's the TR or the small gap with triangular ribbon or the shingle modules. This is in order to include more solar cell within given space. And for the cell parts, that's we should commercialize and ramp up capacity of new cell technologies to make them cost competitive, including the TOPCon, HJT, HIT, HOT, U+, this kind of technologies. And for the wafer, because you know that Jing Solar is vertically integrated, so the cost is not the one-step contribution. It should be the efforts should take in each step across the whole value chain. So in the wafer production side, that to reduce the thickness of wafer without sacrificing quality, and increase the productivity and the production rate of the equipment, and also reduce their power consumption per kilogram. All these efforts we should take we should co-work together to how to say, across the whole value chain to further drop down the cost.
Okay, thanks. There were a lot of points. We'll come closer to, or we'll go into that later on. Henning, so what surprised you most in the last 6 months?
Yeah, I don't know if it's only the last 6 months, but you know, what surprised me the most is if you look at the current silicon costs compared to obviously the prices where we were at the peak of more than $500 per kilo in the past. And since then, always thinking, okay, now we are kind of at a certain, maybe not the bottom, but a certain valley for the silicon costs. And then there's always still room to further decrease. Obviously now in the last week, there has been a bit of a 180-degree turn in that direction, or in that process. But in general, just yeah, also just from the silicon side, how much the industry has been able to decrease cost. And then in the last really few months, obviously this point that people were getting used to power increases being more and more small step, obviously, especially if you look at it in relative terms, percentage-wise. And then all of a sudden, we now see that with the new wafers, and this has been discussed a lot over the last 2 days, that with these new wafers, all of a sudden we see the, at least per module, biggest power increases, which we have not seen for a very long time.
Is Jun still with us, or?
Hi, Michael. Sorry, Dr. Lee, he has emergency, so he has to leave for a while.
Okay. So you take over, and that's fine. Okay. So just let us know. So what do you see from Longji's side as the biggest surprise in the last half year?
I think that everybody has already speak out as the most big surprise that, like in the last 6 months, most of the, module manufacturing, cell manufacturing launched 500 plus watt modules, and even some goes to also say will go up to the 600. I think that is, it seems like it's much more faster than compared to the past several years. And the second part is also, due to the such kind of the big improvement and also the expansions on the production, so that the cost is, I would say the price, yes, market prices drop very quickly compared to our expectations. So this is the biggest surprise in the market.
Okay.
Michael, I think you're muted.
So, oh, I'm still muted. Okay. And so then I repeat myself. So I think if we come to Chiang, and I think I should not ask you what surprised you most, but probably tell us a little bit how you surprised us, because yesterday your colleague showed the roadmap already to 700 watt modules. Can you maybe elaborate a little bit on that?
Thank you, Michael. So, hello, can you hear me?
Yeah,
yes.
Wonderful.
Yes, thank you, Michael. Thank you for offering this opportunity for us to share the viewpoints from Verizon. I think that the 2020 is really a wonderful year. That is a turning point really for the TV industry. So we see so many interesting things patterns, right? So basically, I think that to us, this is just the first year we are changing from semi-lag to semiconductor-like kind of industry. We become have a higher power. We are connecting to the semiconductor industry to the 210, the 300 millimeter, 12-inch kind of wafer. So that is only the beginning. That is only one signal. So to me, I think that the 2020 is a year of ideal come into reality. So our dreams come true. So in 2009, when I was talking together with Charlie Gay, so in Germany, we are talking about that the ideal panel. What is the final panel at the end of the day? So I still keep that paper. We draw a paper to see that module should be a huge module with 210 multiplied by 210. I still keep that paper. So I think that now it comes true. We really changing the thinking style just from testing, try and error. That kind of way to doing things. Now we change to systematically design the things together. Then we see that this is the best choice. So this is, you can see that starting from last year, Verizon have in the industry first putting a 500 watt module marketing to the market. We also ship to our customer at Q1 of this year. So that means that that very fast execution speed. But I think that the important thing for us is that we think that the 2020 offers us really a way of looking at our competition differently, because we are so crazy at benchmarking. So we see that how Jinko are doing, how Longji are doing, how everyone else are doing. But I think that Verizon, we are thinking of we that can we do something different. So I think that the 500 watt is the first thing we have done. That is on the high power. But I think that high power for this 2.0 bringing us the volume because it have a bigger size. Also bring us the quality. Also bring us the standard to a further step. But I think that what is left, we can see that in 2020, people have come out with 500, then 510, 520, 530, 580, 590. Finally, now Antrina and Verizon both have launched together the 600. So we have come up with alignment that we should compete to serve our customer, not to compete with our competitors. The whole industry should work together. Look beyond. Not what is high power really the thing. Only thing we should look at. I don't think so. I think we should look at. So this yesterday, I think Mr. Liu introduced our new low voltage modules. So that is targeting on the lower BOS. So we can see bifacial become popular. We can see that tracking become popular. We will see low voltage modules will become popular. People are talking about high power. People will be starting to talking about low voltage to have higher capacity of power by the single inverter or single tracking system. So I think this is one thing. This is the second thing. But shall we look beyond? So we're talking about 700 watt of modules, right? So Jinko just mentioned about 800 watt of modules. But the important thing we should look at is also the efficiency. So I think Verizon also looking in another angle. We have our parallel production line of heterojunction now generate the highest efficiency in production is 24% above. So I think that will be also very interesting. So we will be working together with Trina, working together with Jay. We also wish lots of all the other competitors, we have become collaborators again. We can push forward from the higher power to lower voltage to higher efficiency, all those things together to generate more values for our customer. Also make an easier life for the supplier ecosystem.
Okay, that's great. So I think that's nice that you mentioned it. Let's get into that discussion. So now we started to talk a little bit about bigger modules. I don't want to really discuss who has the bigger here and the different paths that are. We have that, but in general, so. I don't know if you remember, I think Peter does very well because the module was using sun power cells at that time. And that was actually in the heydays of the Spanish market when the first feed-in tariff was super lucrative and BOS cost didn't matter. So you had 2-axis trackers from a German company called Solon at that time. And they were standing on big pieces of concrete, these trackers, and they had 1 kilowatt modules. That was, I can't remember, 10 years ago, 13 years ago, quite a while. The question is this coming back, this trend? So because okay, so we have now 600, 700, Danny mentioned 800. How far can we go? Because yesterday we also discussed that obviously there are some limitations with transportation. The containers are as they are and they won't be probably changed just because of the solar industry. So what, and of course, yes, at some point we will have the next cell generation coming in, but where is the limit? So maybe Peter first, because I think let's maybe Peter first because he started, or he still remembers the solar module.
I do remember. I don't think there's a limit per se, Michael. I mean, even looking further back than the Solon large area panel, if you go back to some of the early Arco Solar multi-megawatt installations, the panels there were, I think, over 20 square meters. I think Charlie showed a photo or two of these large-scale integrated panels where small laminates were assembled and interconnected in a low-cost fashion and then moved onto trucks and moved to sites. So I think you know, it's really a question of control of the logistics, EPC process, and installation. And to the extent that there is more control over that, I think you could see a return to assembly operations, perhaps portable or robotic assembly operations near to site where containers are no longer a factor. And so the question, I think, perhaps you may or can restate into what is the largest practical single laminate size. I think that's perhaps a different issue. But over time, we could see multiple laminates integrated into a larger individual panel.
Okay. Okay. So anyone else? Some comments also, maybe then what you believe customers are thinking about that?
Maybe I add one sentence.
If I may just jump in. I mean, we also, I think a lot of us still remember the applied materials, what was it, 5.7 square meter module, which also was roughly at that time when the Spanish market was very hot. And those issues which you kind of commented on, Michael, were big issues, right? One was a shipment. Obviously, that was glass, not framed, but still, and the other one was installation. So, frankly speaking, I think, maybe it's a good idea to look at a bit. If we talk about big modules, just look at where big glass plates are used, and over how long a distance these get shipped, because I do believe that shipping costs will play an ever more important role. We are currently now already at what, 10% if we ship to Europe of the product price for shipment. And also, of course, building codes, construction codes, labor codes, in terms of what kind of modules can or are really okay to be handled on site. So I think, without now really being able to give a certain dimension, but I think there will be limits, maybe not technically, but for sure economic and legally, that we will face, and that will put certain limits to just getting ever bigger.
Okay, maybe Verizon first, and then Danny.
Yeah. No, that's in order to increase the power outputs of panels. So there's two ways. One is big wafer, big module. And that's the most tier 1 manufacturers are applying now, but we cannot enlarge the size endlessly, considering the fact that the limit of the laminators, the logistic container possibilities, as well as the compatibility with inverter tracking system and other BIOS components. So, for example, last week we have an inquiry in Spain that the customer wants the higher power, but we provide them two option solutions. One is with hot cut, one is with TR, tiling ribbons. So they do various calculations. They consider that the hot cut solution is relatively not good as the TR solution because of the module, the length of the module is too long. So actually they should pay more on the land cost because of the pitch. And finally they selected the TR solutions. What I want to say is there's two criteria to consider their performance or generation performance of the module. One is the power output. One is the power output. The second is the efficiency. So, for example, our N-type Tiger Pro products that's with the maximum output of 600 watt with the efficiency of 22.4%. So in all, enlarge the size of the module of the wafer is one way, but eventually we should rely on the advanced module technologies, advanced solar cell technologies, and also the process optimization to increase the energy density. That means to add more cell within given space. This is the key point, not focus more on the size of the wafer, the size of the modules. So I think we should focus on.
Okay, Huang?
Yes, I want to share is that I think that the important thing, if you can make a 1 kilowatt module now, you just combine two pieces of module together, right? But that's the really not make sense. So this is why we try to see that the important thing is we need to lower down the voltage of the module. Then you can have a longer string for one inverter, one tracker. That will lower down the BOS, because especially for the tracking system. So this is why we.
You're frozen. We lost you. Okay, and maybe someone else continues. Because I would actually have a point to voltage. I think maybe others have that as well.
See that.
Wait, can you, Huang? I think your internet connection is not so great. Yeah.
Sorry. I lost. Am I back again?
Yeah. Now you're back. I think you're square, yes. But I think you're back.
Yes. Sorry for that. So I mean that the important thing that if we can standardize our module size installations, that will helpful for all the people, benefit everybody. So this is now we are aligning with Trina Solar. So Verizon Energy and Trina Solar unify our 600 watt module standardization. So this is the first thing that ever been done in the industry. We wish that all the others can come into the discussion together, make this one come true for the industry to follow the same module standard. So the third one is the important thing that we really need to look at the efficiency. So the heterojunction is more important than the size.
Okay, so maybe on this, so maybe talk about standardization. So I think we had actually, after Charlie's keynote, also still an interview, but his keynote got so long that we recorded the interview and will air it a little bit later. And so, but we discussed also standards there, and he kind of said, the question is really, how much standards should we really have? Is it also maybe hindering us as an industry if there's too much of a standard? So because when you have a standard, it could also mean that because we are a young and very dynamic industry, it also means, of course, that that sort of innovation is basically staying behind or hindered, because so I think, as I understood, Verizon is already going beyond the 210 millimeters now. So because this guy, yesterday when you proposed the module, I think in order to get to 700, you need 220 millimeter wafers. So so that means that's already beyond a standardization, or?
Maybe I comment very briefly. I think this is not really a standardization, right? It's more, is there kind of a common product that the industry agrees on? And yeah, maybe a bit back to your very first question. So what was surprising or not so surprising during the last 6 months, when a few weeks ago, a couple of months ago, it was very unclear which manufacturer would go for which wafer size at which time. Customers were very insecure, and that yeah, the question, of course, is it then better for the industry that every manufacturer kind of has its own main product, or is it better for the industry what we see now that there are, out of the biggest 6 manufacturers, let's say there are about 2 groups, and yeah, they go for various sizes, but it's not that each one of them goes for a special size.
Okay.
In terms of standardization, I think we are still a very unstandardized industry, right? We are pretty free to do what we want.
Okay, I think Chunk, you wanted to say something. Chang Yu, I think you wanted to say something, or I think you're.
No, I think that I just lost, so I come again, so I'm fine.
Okay.
Okay.
Sorry, I'm kind of the microphone has some kind of problem, so I am getting back. I think so. We're talking about the standardization. Yes, I would say that in the parser half a year, even starting from the later the last year's the module manufacturing, even from the wafer cell to module, that so we are very, I would say, honestly speaking, we're very struggling to select which size of the wafer, and then goes to the also the which size of the module. Because at that time that for the wafer size we have several different options. For the Longji, last year we just launched the 166 wafer size, and then it seems like it's only past less than 1 year. Everybody is starting to consider that the 210. So that's a very, that for us, it's kind of also we were struggling, and we did a lot of the studies, and then, that to choosing what kind of the wafer size is the best one. And the second is also for the module size. I would say that at that time it's except the common module size like 60 cells and 72 cells, and there's some others that goes to the 78 cells. So that is cost of the, I would say, is at that time there's no standard. It seems to become very freely. And after the such kind of the struggling period, and we did a lot of research, and then we finalized goes one point is Longji. We only focusing on not the wafer size or module size, but we focus on what is the best choice for the whole production's value chains, and also for the customer. And so finally we're choosing M10 182 wafer size, and also we launched the 66 cell and the 72 cells with our HIMO 5 modules. So I would say that it's such kind of results. It's not coming from the competing the other competitor. We just focusing on what's the best values and best choice for the customers.
Okay. Gonzalo?
Yeah, I agree with what has been stated so far. I mean, I think the question is also, do we need to standardize it, right? I mean, when you look at the structures, the substructure is not standardized either. Inverters, I would say the same, but also depends on the needs of the market, right? I mean, do you think we will see 182 or 210 millimeter modules on the roof, on a residential roof? I mean, probably not. Maybe in 2 years, it's different. I don't know. But from today, I wouldn't see it. And just as Longji just said, right? I mean, at the end of the day, it's the customer who's going to decide if he prefers this option or the other option. And I mean, the market is growing so strong. We're manufacturing so much. I mean, everybody here in this panel, every company's increasing the capacity. So I think that we have a lot of cost reductions there. So I'm not so worried about about the standardization. And again, at the end of the day, it will be the market who's going to decide. And depending on the segment, on the market, you know, they will tend towards whatever, 158, 166, or 182 to 10. This is the way I see it, at least.
I found it actually also interesting when Shravan did these comparisons between the different efficiencies, but also the power densities. In the end, actually, the modules were pretty similar. Pretty, if I might say so, standing a little bit outside. But the question to me is actually, I also wondered if we're seeing maybe something what we've seen in the cell part before, because if I recall correctly, I think companies really shied away for a long time before they all invested in PERC. You know, they okay, we had the financial crisis, but nevertheless, come on, PERC investment was in the end actually ridiculously low. We're talking about another passivation and we're talking about another laser. So I think we talk about not a lot of investment, and still nobody was doing that. So everybody was waiting as long as possible. Is the trend to larger modules actually also maybe something that companies try to push away as long as possible the need to invest in the next cell technology? Because it is also here not clear, will TOPCon make the, will TOPCon be the technology? Will it be heterojunction? Okay, SunPower has its IBC. They are having their high efficiency technology. Although, of course, here also you can combine heterojunction with IBC at some point maybe. So the question is still, is the trend to larger wafers also a little bit, I don't know, I might exaggerate a little bit, somewhat of a desperation not to, or shying away not to do the investment and take the risk to go now into already the next technology, cell technology, to everyone?
I think that maybe this function, I think that in my point of view, I think the important thing is we want to make profits. That's the important thing. So you know that when the wafer size changes, basically what happens? I need to reinvestment on my equipment. I need to upgrade. So that is a loss of cash wastage, actually. So people are trying to look at something stable, not change for quite a period of time. For example, we come up with the size, this size can stable for at least 5 years or 10 years. So far, we look at from 125, 156, 161, 166, all those things are not a stable size. So from my point of view is that by borrowing the knowledge from a semiconductor, I believe that 210, the 300 millimeter diameters wafer will be a stable size. That will reduce our upgrading cost. So this is why people are trying so hard to do this one first. This is also simple. But this is not the most important thing. This is really not the most important thing. The most important thing is that we need to look at the BOS cost. So that is why we're talking about low voltage. Another thing, very important, efficiency. So the 210 or the 182, this bigger size of wafers shows the limitation of PERC solar cells. So this is the one way to make it delay the time, but more important, people should focus on the standardization of the module. We also focus on make faster adoption of either TOPCon or heterojunction. Although I'm the believer of heterojunction, but at least we should make this one faster, working on the more important things rather than the size of wafers. That's my point of view. Thank you.
Maybe Peter, you have, because you have a very high efficient technology for many years in the market.
Actually, I was going to go back just for a second to the standardization question. Yeah. I think what we've seen, of course, many things when you, in retrospect, make sense. But I think what we've seen in the past few years going from a relatively standard stable product of 6-inch, 155 millimeter wafer, 72 cell module formats. I think there was a period of time when the industry did have a de facto standard. And the cost reduction was so successful that volume increased, and I think manufacturing, we reached a limit in terms of cost reduction potential, where it became much more difficult to achieve incremental cost reduction on that format, and that drove a creative sort of innovation loop, which we're now seeing the results of in terms of larger wafers, different module interconnection technologies. And the question is, where will that stabilize again, if it will? And I think that's really the one of the questions that is one of the basic ones of this conference is will these technologies stabilize in a new standard or not? I think the cell efficiency debate or options is a different axis, and I think they're believers in all of the key technologies. There, I think, are believers in improved PERC. Certainly TOPCon gets a lot of attention. Heterojunction has been around for a very long time. IBC, continued innovation there. So I see that as for the most part, an independent driver than the module size issue.
Okay. So of course, the cost reduction is the cost reduction pressure is there. We have that. So and it will continue. I think because I think we need to also access more and more fields, and the lower we get, we compete with someone else, and then we compete here and there, and so I think it will continue. I think sometimes I get the question also that, hey, look, we've seen now a few PPAs being signed. Actually, I think it's on 3 continents, which is already in the 1 cent per kilowatt hour level. So how far do you really have to still go? Well, as long as we don't have the level playing field, that means we have to compete with subsidized fossil fuels also. And actually also policy frameworks that's not fully adapted to what we need. So that means cost reduction is one way actually of showing how compelling our value proposition is. But the question is really, so maybe somebody else can also take that question that Peter just put on the table. So what will we see in the module now? So will there be maybe at some point also another de facto standard, which we had with 156, or will that be 210, or will there be 182, or whatever it is? It doesn't matter. We don't have to talk about the detail, but will we get to a certain agreement, saturation level, so where everybody can say, okay, we're fine with that, and that makes it easy for EPCs? Because when I was talking to some tracker manufacturers, I just heard only, oh my God, so all these different new modules, all these, and we have to adapt our products to that. So, yeah.
Maybe Michael, maybe I put a short comments that there is a 600 watt plus innovative open innovation ecosystem forum starting initiated by Verizon Energy and also China Solar. So now J Energy, also most of the China glass manufacturers, the inverters, Huawei, like Yangguang, like there are a lot of more people in the industry for all the ecosystem, people joining to discuss. So we want to standardize the module size that will be easier for everyone to have a better life. So we want a stable, standardized wafer size, module size. So based on the past experience, we can see starting from 2005 until now, the semiconductor are using 12-inch wafers. Even the best wafer fab, TSMC investing in Taiwan now, this year is still 12-inch wafer. So that means that for us, at least we have a longer time to use this wafer size. If we can standardize, that will be the best for everyone. So the green energy is for everyone, for all of us to work together to make things simpler. So for the high efficiency, also the same thing. High efficiency is a must. Lower cost, also a must. So that's why we see that hydrojunction maybe because of its simplicity that you have a better chance. So that's my comment.
Okay. Then maybe we can also leave that here because we circled around that quite a bit. So I think let's talk about other ways also of decreasing cost. And I think a long life of a module is for sure one possibility. In his keynote also, Charlie showed actually one slide where a 50-year-long living module, how much impact that has actually in terms of cost, and the question is, does it make sense? Because today there are also even some complaining saying solar is there's hardly few other technologies that have so long warranties as solar, but is this maybe the way to go, that we what can we do in terms of quality without also forgetting, obviously, the cost part of the equation to make modules live longer? That's one. But the first question should be, do we have to make them live longer? Dani.
Yeah. Thanks to the combination of advanced technology and the better and robust material, as well as the improved module design, the solar panel can work well enough within its lifetime. So that's why some tier 1 manufacturers volunteer to upgrade their warranty offerings up to 30 years or even longer. But the question is, it's very interesting. The question is, do we really need to prolong its lifetime? Is it necessary or make sense? Or do we really need an over-quality product? Because that according to the most manufacturers' roadmaps, that's their mainstream output, their power output will be upgraded at least 50 to 100 watts per year. So the so-called high efficient, high power panel will be regarded as extremely low efficient and even waste land in 30 years or even in 20 years. So it's pretty much like the mobile phone. There's no one will use it till its life end. So it's a good question. It's an interesting question that we can discuss extensively in the industry, whether we really need the panel to work for 30 years or even longer. Because lots of the manufacturers, including the tier 1 manufacturers, they have the great pressure of cost reduction. And in the other side, the customer wants the best quality. So everyone asks, we want the best quality with the lowest price, but in most time they're opposite directions. What we can do for the manufacturers, what we can do is to get a balance and to achieve the best dollar per performance.
Yeah, I think that's a great point. Anyone wants to comment on that?
Can I comment?
Yeah, or maybe Peter first and you then Juan.
Yes, yes,
I think one way of looking at this question, Michael, is all else being equal, are customers willing to pay more for a longer life product to the extent that incremental research or different materials are required to do that? You know, I think because of the nature of the project development business, the number of companies that actually hold these assets for a very long period of time, effective discounting on the NPV analysis, I think the answer usually is not much, if you look at from a strictly commercial perspective.
Okay, but there's still a psychological part because people are looking at that somehow. Huh? So,
well, so far, I mean, we started with a very, very inherently long-lived product, you know, and I think there have been continuous improvements made over the years, and so we've been able to achieve both. Really, as you said, you know, there are very few products available that have the kind of lifespan or warranty of a solar module, but that has been part of the mainstream technology development. And I think if you look at a variation of the mainstream technology with higher cost and longer life, that those have been largely niche products.
Might that be also changed if we look at it not only from a cost perspective, but also from a sustainability perspective, I think, which is coming into play also even more? Because of course, the question is also, it's really about materials. You know, at Solar Power Europe, we did recently that report about a study about 100% renewables, and we came to the conclusion that over 60% would be made from solar. So that means alone in Europe, we would have to install, in order to reach that level, 8.8 terawatts, Europe alone. If we just solar, and so that's a huge amounts. And so of course, the longer it lives, the less waste we create, the less recycling we have to do. And with companies also, even corporates now taking more and more emphasis on that. So that is of course also another point of view. Huh?
Indeed. Yeah, as Danny said, you know, this is a topic that we can discuss. We can go around the discussion many times. Generally, in our business, you know, the resolution of these arguments are made by the customers and what they order within the construct of certain policy frameworks. And so I think what you're suggesting would be catalyzed more by some either policy changes or requirements, or, you know, really significant investor perception changes, which are certainly happening, as you said, in sustainability, less so by end customer selection.
But even solar companies are also taking that into consideration when you think about, I think it's not only marketing, but we're seeing that already the first solar companies have just become members of RE100, for example. So that means that we are really seeing also solar companies trying to produce 100% green solar panels. And I think so there is some changes also going on in the sector. That means on the one hand, you're right, we have this cost pressure, and the question is also actually, what do we really need, especially if some investors flip their assets, or at some point next generation comes and then you change the product. But so what is the trend there? Maybe Danny and then Chang, you can comment on that, because I think the both of you have become RE100 members. Huh? So
actually, I want to emphasize one word: quality and reliability is more important than the long lifetime. So especially for this, so much of new things coming in. So important thing, we need to really look at the reliability and quality of the move. That will be the most important thing for all of us. So the passing the IEC standard is not a guarantee of reliability of your module. So we need to be careful on that. So by this, we also working together with World Solar Congress. We have a session to really discussing on the reliability and the quality together with the industry peers. So I think that should be the key focus, not for long lifetime. Long lifetime financially is not making sense for the investor, at least at this moment. So I think that that's a great picture from Charlie. I agree, but that's not the most important thing now.
Okay.
Jing Solar is the first solar company that joined the RE100. In our RE100 roadmaps, we have some steps. First is we invest more on material R&D. That means that more we would like to use more alternative recyclable materials instead of the traditional material, particularly the encapsulation material. And the second is we invest on new and advanced eco-friendly tools and equipments to reduce the waste, to reduce some resource consumptions, gas, water, electricity. And also we set up the systematically EHS systems. In addition, you know that in our expansion plans, we set up our new facilities in renewable rich regions in order to achieve 100% powered by renewables. So we keep pace with the global PV cycle programs and learn good practice from others. So these are some steps we to drivers to meet our ambitious goal.
Chang, maybe you?
I think that, you know, for the back to talk about the lifetime and also quality, such kind of issues, and there's the one thing I think this is a kind of is still not clear in this industry. For example, like the 25 years lifetime is how to measure that. As though we have to wait for the 25 years? No, it's not. It's not possible. So how to measure it at the beginning of when we just finished the modules manufacturing? So that is a great research program for the whole PV industry, and it's honestly speaking, it's not clear now. And second one, as I also agree with everybody's just state that does we really need the very, very long, like 25 years as, you know, 30, even longer lifetime? And what is the best to the customer? Even for the investment, you know, the customer is investment. What is best for them? Do they really need such kind of things? So this is, I think we need to the thinking and also discussion for in the whole industry. And the second is the, even we talking about the lifetime and the warranty, which is not only related to the technology and the product itself, but also related to the companies, this company's stable development, and even the whole industry environment. So this is our comments.
Okay. And maybe regarding this this testing, so as Huang Chang said, do we actually have to change that? Of course, there are tests available that are more stringent, like what the NVDL and PBL are doing, or what DuPont has proposed. Is it because that's also a question of cost, obviously? Yeah. So the more we test, the more expensive it is often. Huh?
Yeah, I think so. You know, like testing, everything now is to go beyond the IEC's standard, even double, triple. But how many times is enough? 4 times IEC standard, even getting longer. So that is a kind of research program for this industry.
Okay.
I just add in one word. I think that the most important thing, you need to know that what is the failure mode. So we need to design the different testing for the different failure mode. So that's very, very important. When you come into the something new, you need to really study the new failure mode.
Mm. I think Henning also mentioned that, of course, I think shipment costs have to be taken into consideration. Danny said that you also look into that you can produce maybe where you have access to green energy. We are seeing, and also we have, of course, now new discussions due to COVID that countries would like to see more local accessibility to certain products. It doesn't matter if it is about in the pharmacy sector, but in the energy sector, that could be, of course, also come into play. And I'm not really even want to talk about into this the whole trade issues that we're seeing around the world, but are we seeing, especially also with modules getting bigger than and heavier actually, that we see a new resurgence of local modcos? Maybe Henning first.
Yeah, well, I think the main point obviously is not if the supply chain does not get localized as well, right? So if the module production would just be more or less an assembly, but most of the materials, let's say the market is in Europe, the assembly takes place somewhere in Europe, but most materials still come from Asia, then obviously not much would be won. And seeing that the silicon costs are decreasing, obviously higher power per module also to a certain extent decreases the BOM costs, but it would be a very big or quite a long way still to really relocate production of standard products or mainstream products, because again that would also mean that the supply chain would have to be localized as well, or major parts.
Other views? Other views on this? I think so. We've seen, because I think we've seen actually Malaysia also pop up as a new hub recently. So which offers also some access to green electricity also, and is outside China. So, but Danny?
And the Think Solar strategy, long-term strategy, is from global sales to global production, then to global investments. So we are the first one to invest in Malaysia and then in US. But for us, the strategy or the globalization strategy is not big challenge. The big challenge is, that's now we are in the same stage. The whole world is in the same stage. It's very transparent. The price is very transparent. The cost is very transparent. And it depends on whether the customer, they would like to pay 3 cents more of your products made in US than in China. So in order to make it's very easy, or for us, it's relatively easier to set up a new factory in US or in Europe or any countries. It's not a challenger, but the challenge is how to make it profitable, how to make the factories profitable, and how to make your products has the same quality, has the same, and as well as has the same cost of what you made in China. So this is a big challenge, because there's a lot of the factors to impact your final cost, like the labor cost, or whether it is accessible to the cheaper resource, or whether you have the complete supply chain locally. So it's a big challenge. So for us, our strategy is very clear. from global sales to global production. But we should be very careful for the to select the destination country.
Other comments on this? Yeah, Gonzalo?
I agree. I mean, I agree with Huang, who said at the beginning that we're here to be profitable and make money, because if we don't make money, we have to close down for obvious reasons. I agree with Henning. I mean, yeah, transport costs are becoming more and more important because prices, or the module price is going down. But as long, and of course with Danny, I mean, as long as the transport cost, you know, is still below what we can save on the manufacturing costs, it makes no sense to bring it to Europe. Coming back to what I said at the beginning, when I was in semiconductor, we had the same discussion. We also had a factory in Germany for obvious reasons, but then we were bringing everything to Asia because it was cheaper. And you had it with the same with the computer industry. Everybody was saying, why is HP, Dell, IBM manufacturing with Foxconn and all these people in China or in Taiwan? You know, yeah, they were discussing also, let's bring something to Europe, but in they were manufacturing something in Europe, but it was peanuts. You know, it was 100,000, 200,000 computers, which is nothing. And yeah, I think we all know what happened to the European manufacturers. I mean, you mentioned Solon before, Michael. And, you know, you have many examples in Germany. Yeah, you name it, Solar World, Solar Fabrik, et cetera, et cetera. It's difficult to go compete. And at the end of the day, it's about, yeah, where do you get the best opportunities and where can you make your business profitable? And this is definitely, I see it very difficult in Europe to be precise.
And sorry to jump in, just this point again on local supply chain. This is really key, right? Because module production locally does not necessarily mean lower shipment costs. If you still have to bring the glass, the frames and everything in from Asia, then it may even be more expensive because you still have to fly over the cells or the wafers if you have a cell factory, a local one. And your factory may not be at a port, so you have even higher inland transport costs or continental transport costs. So again, without a local supply chain, I think it will be very hard.
Peter, maybe I think you have, actually you've even bought not long ago, SunPower has not bought long ago, actually has taken over the SunPower factory in the US, and you inherited also module factories when Total invested in you in France. So that means you have also production in rather high labor countries. But I think costs have now changed. So has the view and actually the economics also changed?
I think the history of decentralization of module manufacturing has been driven primarily by trade policy, tariff barriers and other things. Incentives, purchase incentives. I agree with Henning that when you think of that in a longer term commercial framework, a lot of it depends on the localization of the supply chains, and we haven't really seen that to a large extent yet outside of Asia. So clearly, higher automation, which we're seeing now almost everywhere, decreases the labor impact, but there are, Danny talked about our customers willing to pay more for a product made in the US. I think over time we will see some distribution. I think it's logical over the long term that we'll see more distributed manufacturing, but it's going to be driven by supply chain localization, I think, at the end of the day.
Okay.
I just want to add in the one point is that for the global manufacturing that there's another challenge is whether it's possible to find enough qualified people to, even for the worker and also qualified management team. So that is also another thing when we consider that manufacturing from doing manufacturing as a different country and place.
Yeah, I think that's a good point. But at the same time, we're also seeing something different, because when I looked at the presentations yesterday, some of your colleagues were showing simply expansion targets, and that was mind-boggling. So I think hardly none of the companies will have module capacities under 20 gigawatts next year. The first ones are entering the 30 gigawatt level, or striving to reach that. What does that mean when we see all our discussion about quality, about cost, and we see this huge investment at the moment going on, and on the other hand, the market also being still, although diversifying, still depending on a few countries. So we've seen the sort of China disappointment in the last 3 years, what we've seen in Europe a long time ago, that the Chinese market, because of market restructuring, went down, and caught everyone by surprise and took much longer to recover. Everyone hopes that we are back to 40 gigawatts this year, but so that means there can be dramatic impacts if one or the other market still switches off, and everyone is so investing so much, and so how does that actually influence also the design of the modules and the costs we have to look at?
Maybe I have some words on this. So I think that for solar, one of the important things is kind of energy. You have no feeling of this energy. So I think that, to my point of view, I feel that this energy should be much cheaper in the future. It needs to be much cheaper. Then it's easier for all to making in all over the world. People will be able to see that, okay, I will not look at the price. I will look at something I like. But that will happen after 2025, in my point of view. So the important thing is that the heterojunction need to be the mainstream. Then you come to the tandem cells. So when you look at this, it's too cheap. No need to look at that again. Like we look at cars. In the first time that we look at all the cars, the best car is the black car, right? So then the car become very, very cheap, then people starting to look at different kind of cars. So I believe that when solar cell efficiency reaching 30% of solar cell efficiency, maybe 5 years later, then I think that will be much more easier for people to generate solar cells everywhere.
Any other thoughts, considerations about this huge expansion wave that we're seeing on, and actually also what that means for the product itself?
Well, I think in general, it depends, of course, is the expansion only on the modules, or is it also on the more midstream and upstream parts, right? Because the more a company has a non-balance of the various capacities of the silicon supply chain, the harder it is to control quality, and the less secure the customer can be that the quality is really controlled. So from that perspective, for a customer, maybe it makes it harder to make choices in the future, because the customers may have to go in deeper to really check not only where does the module come from, but also cells and wafers. From a industry structure, I think what we are seeing this year, that even with a, according to the current forecasts, slightly smaller market than last year, the volumes of the top manufacturers are all increasing. So what we are seeing is, of course, that the top manufacturers are growing in market share. Yeah, I think this trend will also keep going on in the future, in the next few years.
But will we see, I think, because there are two different strategies, right? Because there are some companies that are have actually even more vertically integrated over time, so that wafer manufacturing even more matches their module output, while other companies actually have rather focused on cells and modules and maybe increased or even expanded into BOS, like Trina, which bought a tracker company, for example. So, will every company has a different strategy, or will we see some consolidation also going on? Like, for example, I think we're seeing for sure one in the silicon industry at the moment. Even new players coming on, for sure, but still others being driven out of the sector. And I think some manufacturers obviously also now under pressure with all these new investments that have to be made. So what are your thoughts actually? So in the on these strategies. So what will we see in, let's say, 5 years? Will everyone be fully integrated, or will we just have a few full integrated companies and then two big wafer manufacturers? Or Danny?
I fully agree with you. This topic depends on the company strategy, particularly the long-term strategies. And for example, the Jinko Solar, we always ask ourselves whether we want to be the largest manufacturer or want to be a great company or a clean energy company. So now when we solve the first problem of cost and scalability, what's our next? That's the next for the industry, solar industry. The next bottleneck is the energy, because that's the solar has its nature shortcoming or weakness. That is the energy intermittency, and as well as the in the future we will have few available land, and also because it's the decentralized energy, so there's a lot of the data isolations. These are three key problems of this industry further developments. So for Jinko Solar, we insist our vertical integration. So our capacity of wafer, cell, and module is in the same page or is in line. Our next step strategy is to solve what I mentioned, these three questions. That means we will develop on like the storage, like the BIPV, or as well as the smart meter, or kind of the things to not simply to expand the capacity, but we will be, how to say, the horizontal, to extend our product portfolio or solution portfolio.
Michael, yeah, I think it's unavoidable that there will be a consolidation in the market. I mean, right now, as you just said, I mean, everybody's expanding capacity. Everybody here in the panel is expanding, going towards 20, 25, 30, whatever gigawatt. And we're lucky because the global market is growing. So, you can bring more and more capacity. But there will be some point, I don't know, maybe not next year, no, but maybe 2 years and 5 years and 10 years, where the market will not grow anymore. And then there will be a bloodbath, right? And then, yeah, we will be fighting against each other to maintain or win market share, because the market will not grow further. And then there will be consolidation. I mean, you have this in every industry. I don't want to repeat against semicon, because then you will not invite me next time. But you can take semicon, you can take automobile industry, you can take the airlines, just pick one industry, and you will see that once they started, they were, I don't know, 20, 30, 40 players. And now at the end, they're like 3, 4 big players who have like 80% of the market, and the rest, some smaller ones who have 10, 20% left. And in my opinion, this is going to happen here exactly the same.
Peter, what do you think? So I think we just discussed that when we recently.
Yeah, I think the trend that we're seeing in the industry is toward more consolidation for sure. I think the question you started with on kind of horizontal versus vertical structure is an interesting question. I think we're seeing, we saw a little bit more of a trend towards horizontal focus, i.e. specialization in different parts of the value chain. There are also you can always find counter examples, both in other industries and within solar. I think as the industry matures, my personal view is we'll see more of the horizontal focus. And I think at the end of the day, you know, like in most industries, technology or consolidation will be driven by differentiated technology, you know, strong brand and channel focus, customer preference, access to capital, sort of the usual factors, all of which I think are playing out currently. So it'll be the next few, you know, we say this every time, Michael, but I think the next few years will be particularly interesting.
Yeah, I agree. Anyone?
I think that there will be vertical integrated players. There will be specialized players. But for the healthy development of the industry, we need both. But the most important thing is that what are the next big things that will be the important thing for us to consider, that whether we are in that big train. For example, the bigger wafers. We are discussing bigger wafers. So we mentioned about the low voltage to lower down the POS. We mentioned about high efficiency. So which technology will become the winner, for example, whether that will be a heterojunction. So all those things will really determine the fate of the company. So I believe that innovation will determine the future for us. So that's our opinion.
Okay, I think that's a great, maybe let's come to the final statement. That was almost, I think, a great final statement. So what to everyone, maybe if you look at the next 10 years, so when we look at, hopefully that will be a somewhat of a solar decade where we will see massive deployment of solar. But in any case, what do you think is important that this happens so that in 2030 solar is really getting closer of becoming a major technology? And maybe as part of that, because this is really about modules, how do you think a solar module could look like in 10 years? So I think there were so many interesting ideas. Also, whatever you think, if it should last long or not so long, and it should be sustainable, because there were also these fancy technologies at some point. I don't know if you remember Apollo Nice in France, when they just had 2 glass panes actually that was isolated, so they could do without any EVA and backsheet, and the cells were actually held by the vacuum. So whatever it is, because of course you would get rid of all the polymers in the end. So from a sustainable point of view, that would be also great. So what would solar or a solar module look like in 2030, and what's really important to get us to have a high quality, low cost product in the next 10 years?
Maybe I answer first. First. So very simple. 210. That is now. Low voltage. That is now. Plus heterojunction. Plus conduct. Finished.
Okay. John, maybe you?
I think the first one that though I still have the very bright benefit, believe for this industry, because the PV industry, the end market demand is still growing up, and this market existing. So then everybody's industry can play a lot of stories. So this is lucky for us. Even, this period we have, sometimes we have very difficult times, sometimes we are happy, make money and whatever. But in the next 2030, I think if this industry can, goes really free in a market, not rely on the competition from the government, not only rely on the policy, then that will give us a big space to play this industry. I think at that time I think we can move our eyes from the cost.
Okay.
That's a very, I would just like to say, it's a great hopes that I would like to say.
Okay, and then since you have a technology background, what kind of module would you see in 2030?
Technology background, I would say that is no matter from the cell of wafer cell and the modules for the Longji, we focusing on what is best and suitable technology at that time we will choose.
That was very diplomatic. Okay, maybe Peter.
So one of the things that is striking, I think, about the industry, Michael, is that for 40 years plus, the technology has been kind of multi-purpose. We've made a basic thing, and it gets applied to very, very different applications, from residential rooftops to power plants. So what I would expect to see in 10 years is more specialization, more diversity of products. As the cost of the basic solar panel comes down, I think modification of the product to incorporate end use attributes. So AC modules for residential roofs, larger panels for power plants, still perhaps with the glass construction, maybe even non-glass products for certain applications in the future. I think we'll see greater diversity of product types in that period of time.
Mm-hmm. Okay, very interesting. Yeah. Danny?
So I have bold imaginations that in 10 years or even longer, I think at that time, I hope at that time, solar industry disappears, because the solar module or the solar cell is integrated into all the materials, like the building materials, like the steel materials, stainless steel or concrete, or even the facade materials. The solar cell is integrated into all these materials that can be exposed under the sun and that generate by itself. Rather than they're like today, the solar panel is still an individual independent power generation products. We hope that in the future it can be, or the solar cell can be integrated with more materials, and let the building or like the architect can generate and consume by itself.
Okay, thanks. Henning?
Yeah, first of all, I think, it really has to become a solar decade, right? It should not just become a solar decade, but it really has to become a solar decade. And secondly, I think, as another broader comment, the manufacturers should really start or have to be creating much more demand and not just serving demand. On the module, what will it look like? I mean, I would be somewhere between Peter and Danny, I would say. So going back to, you know, consolidation and what we saw in other industries, yes, we saw consolidation, but normally, or what we also saw, once prices were at a level affordable to the end users, to customers, we also saw a higher diversification of products again, although there was a consolidation on the number of manufacturers. And I believe we will see this in solar power, and we will see a much higher number of customized tailor-made products which will fit various or different applications.
Okay, thanks. Yeah, Gonzalo?
Oh, it's difficult to say what the future looks like. And when I started 11 years ago at well, we had the 200 watt panels. I mean, if you would have told me at that time that we would have 600 10 years later, I wouldn't have believed it. So yeah, I think in 2030, for sure we'll have a product that will help to reduce the BOS cost. It will be competitive, and it will help us reduce the price of electricity, the LCOE. And yeah, I agree with Huang. I mean, I personally believe it goes in the direction of heterojunction, but I think this is honestly not so relevant because 10 years is still so far away. But for sure, it will be a module that again will help us reduce the BOS, and hopefully, just as Danny said, it will be integrated in many products so that we're not selling just modules, but something integrated into other devices.
Okay, super, thanks. I agree with all of you. I agree with Henning in particular that we really have to have a solar decade. I think that's what the world needs. Otherwise, we will not meet the Paris Agreement targets. We are the main pillar. I think it's on our shoulders, and so we have to make it happen. And if obviously we are reaching that level that Danny just mentioned, that solar is just a part of many things, then we would have probably reached that level and that target, because then we would be a building material, we would be whatever, part of roofs, part of everything. So that's what we're striving for. I think the industry is ready. Again, as I always say, politicians are unfortunately not. We have to work on them. They are putting, often at least, stones in our way. I think we're working on that as well, all of us. I want to say thank you to everyone, to each of you for joining us. For some it's very, very late, for some it's very, very early. It's still great that in times of COVID we are able to have such events. I was really happy that we at TaiyangNews were able to get this conference together with the support of you. So thanks for that. And I think this should be from our side, because we consider us as a technology platform, and I think this is our mission, to make technology available to each and everyone, also on a level that's very in-depth, and people can nevertheless access it without having to pay a large amount to consulting reports. And so we would like to take this this conference also as our first and continue it in the future. So thanks again. So our next, so this is our report, which we will publish on Saturday with the updates we learned here, integrate that tomorrow. And then we would like to say again, thank you to the sponsors and SNAC for helping, supporting us to also distribute the report next in 2 weeks at their event. And then also announce our next event that will be even more technical and more focus that will be based on our new market survey on solar backsheets and encapsulation materials. And yeah, we don't have the date yet, but it will be very soon. Again, thank you to everyone, also to the attendants. Thanks for the many questions. Even if they got unanswered, we have noted them down, and we have the chance, unlike probably many other conference organizers, that we will integrate or try to at least integrate some of the answers into our upcoming reports, because the questions were very valuable. Time was unfortunately short that we couldn't integrate everything, but we will try to do that later on in our reports. Thanks again. Have a nice day and see you all soon. Bye-bye.